To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
So my dear children, in the earlier chapter we discussed several MCQ questions, several extra MCQ questions related to the lesson electrolysis. So within this chapter also we'll be discussing several MCQ questions first, but after that I'll be moving on to the essay type questions. So let's head on to observe question number 31 onwards. A solution that contains mobile ions. So solution that contains mobile ions, that means it should be an electrolyte. So what are the examples for electrolytes? Acidulated water, acids and bases, then solutions of ionic compounds. So you have to select one of these four categories. So a solution that contains mobile ions, then lime juice, acidulated water, vinegar above all. Lime juice is a good acid, so it is correct. Lime juice, it is a good acid, so it is correct. Acidulated water, once again correct. Vinegar, once again an acid, so it is correct. So my dear children, all of these things will contain mobile ions, all the above. Next one, metals conduct electricity because. Metals conduct electricity, remember they are asking about metals. So we know that electrolytes conduct electricity because they have mobile ions. Metals can conduct electricity because they are having moving electrons, or these things are called as free moving electrons or mobile electrons. So within a metal, I told you that electrons contained within the metal can be freely moved, or it can freely go here and there within the metal itself. So therefore electrons are mobile in metals. Okay, electrons are mobile in metals. That means, my dear children, metals contain mobile electrons or moving electrons, not ions but electrons. So those have mobile ions, incorrect. Those have mobile atoms, once again incorrect. Those have mobile electrons. As they have mobile electrons, they can conduct electricity. Okay, they can conduct electricity because they have mobile electrons, my dear children, right? When a solid is heated and brought to the liquid state, then it is called as, when a solid is heated and brought to the liquid state, that means fusion. So therefore it is referred as a fused substance or else a molten solution. Fused solution means the same. Okay, so I'll mention fused also. Fused solution is also the same, right? Fused solution or molten solution. Next one, nonmetals are insulators of electricity because those do not have mobile ions. Of course it is correct. As they do not have mobile ions, those things are insulators. Those have mobile atoms, incorrect. Those do not have mobile electrons or ions. This is the most suitable answer. As they do not have mobile ions or electrons, right? However, my dear children, this thing is also correct. See, those do not have mobile electrons. Those do not have mobile electrons. Of course, they do not have mobile electrons or else ions. So both of these things are correct. So the most appropriate answer would be, as they do not have mobile ions or electrons, right? Then these things are considered as insulators of electricity. So they won't be able to conduct electricity. Okay, right? During electrolysis, right? So you have to select the correct statement in 35. During electrolysis, electrolyte is converted to complex substance. Incorrect. During electrolysis, my dear children, we know that electrolyte is converted to a simpler substances, right? Or it is getting converted to simpler substances. So this is totally incorrect. During electrolysis, It's not getting converted into a complex substance but to a simple substance, right? So we have to select the correct answer, okay? Molten solutions of metals do not conduct electricity. Incorrect. Incorrect. Molten solutions of metals, they can conduct electricity, no problem at all, right? We can observe a metal which is in the liquid state in normal room temperature, that is mercury. Mercury is a good conductor of electricity. Even though it is a liquid, it is a good conductor of electricity because it has mobile electrons. Each and every metal has mobile electrons, okay? So it is a good conductor. So metals are going to be a good conductors of electricity, okay? No matter the state, metals are good conductors of electricity. Next one, molten solutions of ionic compounds conduct electricity. That is correct. No problem at all. Molten solutions of ionic compounds conduct electricity because we discussed that when you take an ionic compound, no matter the state of liquid, it can be aqueous or molten, right? Or else a fused solution. No matter that, it will definitely conduct electricity because of having mobile ions. Next one, petrol is conducting electricity. Once again incorrect. Right. 36. Select the correct statement. Once again you have to select the correct statement. During electrolysis of copper sulfate, solution turns to dark blue. During electrolysis of copper sulfate, solution is getting turned to dark blue. Totally incorrect. Actually, it is getting converted into light blue solution because of the absence or because of reduction of copper atoms, right? Actually, it is not atoms, copper ions, right? Copper ions. Because of reduction of copper ions, it is the color of the copper sulfate solution is getting reduced, and with the time it will take a light blue color. Next one, for galvanizing, electroplating is not used. Once again incorrect. For the process of galvanizing, we use the process electroplating. So it is incorrect. Metal which is to be plated must be used as negative terminal during electroplating. That is also incorrect. Why is that? Because metal which is to be plated, the metal which need to be plated, right? So the metal which we need to plate to a different object should be used as the positive terminal and the negative terminal should be the object. So it is incorrect. Next one, metals do not have mobile ions. Metals do not have mobile ions. What can you say? Actually, this is correct. Metals do not have mobile ions. Metals do have mobile electrons or moving electrons, free movable electrons. So therefore, within metals, we won't be able to identify mobile ions. Okay, right. Select the incorrect statement, incorrect one. Okay. During electrolysis, a chemical reaction occurs. Right? During electrolysis, a chemical reaction occurs. That is absolutely correct because we know that resulting a chemical reaction by providing electricity to an electrolyte is the electrolysis. So it is correct. Electricity is compulsory for electrolysis. Once again correct, right? We need to provide definitely electricity. Otherwise, the electrolysis will not occur. So electricity is compulsory. Bases do not conduct electricity. This is incorrect, my dear children. We know that bases are good conductors of electricity. So therefore, the sentence which is given here, bases do not conduct electricity, is totally incorrect. Final one, sugar solution is not having mobile ions. Correct. Therefore, sugar solution will not conduct electricity. So it is correct, no problem. Next one, select the incorrect statement. Once again, you have to select the incorrect statement. During electrolysis of aqueous copper sulfate, oxygen emits. During electrolysis of aqueous copper sulfate, oxygen emits. During the electrolysis process of aqueous copper sulfate, oxygen is going to emit from the positive terminal. So it is correct. Tin is plated on iron using electrolysis. Correct. Tin is plated on iron using electrolysis, right? So the sardine tins, okay, then other different kinds of tins that we use, okay, is plated with the metal called tin. So here we use the process of electroplating. So it is correct. In a high quality electroplating, coating is shiny. Correct. In a high quality electroplating, coating is shiny. We even discussed this thing under the factors or the characteristics in a high quality electroplating. Okay, so it is correct. Most of metals can be used as electrodes during electrolysis. This is incorrect. We can't use most metals as electrodes during electrolysis because the metal will react with the solution and therefore we won't be able to get the necessary observations or the necessary result. The metal that we can use as an electrode during the process of electrolysis is the platinum, because platinum is an inert electrode, but however other metals are not inert. Okay, right. Then the next one, application of knowledge of electrolysis. Application of knowledge of electrolysis. First one, to make electrochemical cells. Of course, to select the metals which are important for the electrochemical cells, we use the electrolysis process, or we use the knowledge of electrolysis. So it is correct. Next one, to extract metals. That is absolutely correct. No, we know that sodium and aluminum used to we use the knowledge of electrolysis to extract metals like sodium and aluminum. So it is correct. Next one, galvanizing. Of course it is correct. So all of these things are correct. Next one, chemical formula for copper sulfate and common salt separately. Copper sulfate and common salt. So I'll write this thing. Copper sulfate, CuSO4, copper sulfate. Sodium chloride. These things are very important, my dear children, right? Sodium chloride. NaCl, sodium chloride. So copper sulfate, CuSO4, sodium chloride, NaCl. Chemical formula for copper sulfate and common salt. Common salt is sodium chloride. Okay, common salt. So the correct answer would be, my dear children, copper sulfate, CuSO4, common salt, NaCl, right? Okay then, so we have discussed several MCQ questions related to the lesson electrolysis. Now it's time to discuss different other types, right? Here we are mainly discussing several essay type questions, my dear children. So here you have to write down the answer, or else you have to select any other different thing. Okay, sometimes it can be matching or putting ticks or incorrect things, or else sometimes filling the tables using experiments and so on. Okay, so we'll head on to see what are the essay type questions related to the lesson electrolysis. Okay, right. So the second question, you need to write down the correct answers here. First one is given, describe the meaning of electrolysis in brief. So what's the meaning of electrolysis? It's very simple. Electrolysis is the process of creating a chemical reaction by providing electricity to an electrolyte. Okay, so we can write the answer, process of creating a chemical process of creating a chemical reaction by providing electricity to an electrolyte. Right. So the process of creating a chemical reaction by providing electricity to an electrolyte is called the electrolysis. This is the one which is called as the electrolysis. Next one, what is called as an electrolyte? Very simple, my dear children. We know that solution that can conduct electricity. So a solution which can conduct electricity is called as an electrolyte. Okay, right. Next one, write 3 categories of electrolytes with an example. 3 categories of electrolytes with an example. So number 1, acids. So we can mention hydrochloric acid. Example. Hydrochloric acid and sulfuric acid is also correct. Okay. Number 2, bases. Examples for bases: sodium hydroxide, solution. Remember, these things should be present as solution. Okay, sodium hydroxide solution. Then number 3, aqueous. Right, or else we'll mention as solutions. That's better, no? Right, solutions. That means both are getting covered, aqueous solutions and molten solutions both. So solutions of ionic compounds. Solutions of ionic compounds. Example, sodium chloride solution. Right, sodium chloride solution. So acid solutions like hydrochloric acid conducts electricity and it is an example for electrolyte. Bases like sodium hydroxide solution, good example for electrolytes. Then solutions of ionic compounds like sodium chloride solution, good example for, once again, for what? These electrolytes. Okay. Next one, what is called as a non-electrolyte? What is called as a non-electrolyte? Non-electrolyte is a substance or else a solution which cannot conduct electricity. Solution which can't conduct electricity. Right, so a solution which can't conduct electricity is called as a non-electrolyte. Okay, this is a non-electrolyte. Next one. Write 5 examples for non-electrolytes. 5 examples for non-electrolytes. Okay. Kerosene oil. Number 2. Distilled water. Distilled water. Number 3. Coconut oil. Coconut oil. Number 4. Petrol. Petrol. Number 5. Glucose solution. Glucose solution. So, kerosene oil, distilled water, coconut oil, petrol, diesel, glucose solution, sugar solution. These things will not conduct electricity as they do not contain mobile ions within the liquid. Right. Write 3 examples for ionic compounds. 3 examples for ionic compounds. So, sodium chloride. Magnesium chloride. Right, magnesium chloride. Then potassium nitrate or else sodium nitrate. We found that sodium nitrate thing, right? Or else we'll use another different metal here. That's good, no? We'll use a different metal. Like we'll use potassium. Potassium is already being used now, so we'll use a different one. We'll use silver nitrate or copper sulfate. Copper sulfate is more often being used now. Copper sulfate. Right. So you know that, right, these ionic compounds, they contain a certain type of a metal. That's why these things are referred as ionic compounds. So within ionic compounds, you can observe a metal. Sodium chloride. Sodium is a metal. Magnesium chloride. Once again, magnesium is a metal. Within copper sulfate, copper is a metal. So ionic compounds contain a metal. Right. Divide given solutions into electrolytes and non-electrolytes. Okay, so we'll divide these things. We'll use a table. I'll use a table, my dear children, and we'll divide. So, electrolytes, okay, electrolytes, here non-electrolytes. Right. Sodium nitrate, as sodium is there, definitely it is an electrolyte. Sodium nitrate. Sodium nitrate. Kerosene oil, non-electrolyte. Glucose. Glucose is once again non-electrolyte. Lime water. Lime water means calcium hydroxide. Calcium hydroxide is lime water. Right? Remember. So as you know, calcium is a metal. So calcium hydroxide can conduct electricity. So lime water. Lime water. Next one, diesel. Diesel is not a electrolyte. Next one, liquid nitrogen. Once again the same. Liquid nitrogen is used as a supercoolant. To cool different objects as a supercoolant, we use liquid nitrogen, okay? Liquid nitrogen. Candle wax, once again the same, right? Candle wax. Finally, pineapple juice. You know that pineapple juice is a good acid, so it is an electrolyte. Right. So, sodium nitrate, lime water, pineapple juice. These things are electrolytes, and my dear children, kerosene oil, glucose, diesel, liquid nitrogen, candle wax. These things are non-electrolytes. Okay. These things are non-electrolytes. Right then. Draw and show a labeled diagram for the electrolysis of aqueous copper sulfate solution. Aqueous copper sulfate solution electrolysis. So I have to draw a labeled diagram. Let's draw. It's very simple, no? As there are no metallic plates are being used here, it's very simple. So you use a beaker like this. Okay, then the solution. Then the two carbon rods, my dear children. Here we use, you know that carbon rods are being used here. Inert carbon. Right. Then we provide the electricity. Here we go. Right. Then this is the solution. Copper sulfate. These are the electrodes. Very simple. Carbon electrodes. Right. So carbon electrodes and the copper sulfate solution. So here we can observe air bubbles coming out from here like this. From both the terminals. Right. Here at the negative terminal, you won't be able to observe air bubbles, but however, you will be able to observe like a brownish color copper like this. Okay. So this is the labeled diagram for a electrolysis process of copper sulfate solution. Okay, you just use carbon electrodes and you place the copper sulfate solution like this, and my dear children, connect the two carbon electrodes to the dry source. Okay, right. So from the positive terminal, gas bubbles will evolve, and at the negative terminal, copper will deposit. Okay, then the next one. Write all possible observations during the electrolysis of aqueous copper sulfate solution. Right. So we'll write down the observations of copper sulfate solution. Number 1. First one. So this is a continuation of the previous question. Okay, continuation of previous question, my dear children. So the previous question was asking about the electrolysis process of copper sulfate. So this is a continuation. Let's see. So write all possible observations. Number 1, oxygen gas emits from positive terminal. Number one, first observation, right? Next one, number two, blue color of the solution right, blue color of the solution reduces. Number three, third and the final observation would be copper is getting deposited on the negative terminal. So these are the three observations, my dear children. Number one, oxygen gas emits from positive terminal. Blue color of the solution reduces, right? Blue color of the solution reduces. Then next one, copper is getting plated or copper is getting deposited, right? Copper is getting deposited on the negative terminal. So these are the three observations from the process of electrolysis of the aqueous copper sulfate solution, right? Then let's head on to the next question. Name two acids that used to create acidulated water. What are the two acids that we can use to make acidulated water? So we can use hydrochloric acid, right? Hydrochloric acid, or else we can use sulfuric acid. This is also referred as battery acid, sulfuric acid. So hydrochloric acid and sulfuric acid. Explain why acidulated water act as an electrolyte. So you know that when adding acid, ions within the water is getting separated and they become mobile. So therefore, acidulated water contains mobile ions. Okay, so we can write the answer. When an acid is added, right? When an acid is added, ions are getting removed. Ions are formed. We'll try to keep the thing in very simple. So when an acid is added, ions are created within water. As H plus and OH minus. These ions can freely move within acidulated water. Right? Okay, so therefore acidulated water Therefore, acidulated water conducts electricity. Right. So, what is the answer? When an acid is added, ions are created within water as hydrogen plus and OH minus. These ions can freely move within acidulated water. Therefore, acidulated water conducts electricity. Therefore, acidulated water conducts electricity. So, I'll use the conduct electricity thing in here. Right? Electricity. Right. So, this is our answer. Once again, when an acid is added, ions are created within water as H plus and OH minus. So, these ions can freely move within acidulated water. Therefore, acidulated water conducts electricity. This is our answer, my dear children. Right then, the next one. Explain why distilled water acts as a non-electrolyte. Very simple, my dear children. Within distilled water, there are no mobile ions. So, there are no any mobile ions there are no any mobile ions in distilled water. Right? There are no any mobile ions in distilled water. Therefore, distilled water acts as a non-electrolyte, my dear children. Right? Explain how metals can conduct electricity. Very simple. Metals have mobile electrons. So, therefore, electrons will provide or electrons will facilitate the conduction of electricity. Okay. So, we can write the answer. Metals contain metals contain free moving electrons. Free moving electrons which helps to conduct electricity. Which helps to conduct electricity. So, metals contain free moving electrons which helps to conduct electricity. So, my dear children, because metals are having free moving electrons, these free moving electrons will help to conduct electricity. Okay, these will help to conduct electricity in metals. Right then, the next question. Write 3 applications of electrolysis. 3 applications of electrolysis. Very simple, my dear children. Number 1, in electroplating. Right? In electroplating. Next one, number 2, in making chemicals. In making chemicals. Examples, caustic soda. Right? Then metal extraction. right? Metal extraction. Example, sodium. Right. So these are the applications of electrolysis. In electroplating, we use the process of electrolysis. Then in making chemicals like caustic soda, we use the process of electrolysis. Then in metal extraction, we use electrolysis like sodium. Right, 3 applications of electroplating. So here we have to use the process of electroplating, my dear children. So electroplating, number 1, galvanizing. Galvanizing. Number 2, plate tin on metal. Plate tin on metals, right? Then number 3, in making ornaments. Right? In making ornaments like vases, plates, then spoons, forks, and so on. So in making ornaments like vases, plates, spoons and forks, and also when plating tin on metals, and also in galvanizing, we use the application or we use the knowledge of electroplating. Right, my dear children. Then the next one. Write 3 features of high quality electroplating. 3 features of high quality electroplating, right? Number 1, should have uniform thickness. Right? Should have uniform thickness. Throughout the object, my dear children, the thickness should be uniform. Next one, number 2. Second one, should have a good shine. It should have a good shine. The coating should be shiny. Okay, it should have a good shine. Number 3, my dear children, the plating or the coating. Coating should be firm. Right? Firm. Coating should be firm. Firm means it should firmly adhere to the object. Okay. So it should have a uniform thickness. It should have a good shine. Then coating should be firm. Right? Coating should be firm. Next one. Right, 2 observations during electrolysis of acidulated water. 2 observations of acidulated water. Very simple, my dear children. Number 1, gas bubbles, right? Emits from both, right? Gas bubbles gas bubbles emit from both positive and negative terminals, right? This is the first observation. Gas bubbles emit from both positive and negative terminals. Number two, gas bubbles emit at higher rate right? Gas bubbles emit at higher rate near the negative terminal. That means we can collect more gas at the negative terminal, because at the negative terminal hydrogen is the gas which is getting produced. So the concentration or the amount of hydrogen gas which is going to release is greater than oxygen. So therefore, my dear children, gas bubbles emit at a higher rate, right? Gas bubbles emit at higher rate near the negative terminal. And the other observation is that from both the terminals we can observe the emission of gas bubbles. So gas bubbles emit from both positive and negative terminals. However, we can collect more gas, right, from the negative terminal. That means the amount of hydrogen which is released is more than the oxygen, right? Then the next question, write 3 features of a metal which is used for electroplating process. 3 features, very simple. Number 1 should be shiny. It should be shiny. Next one, number 2, resistant, right? Resistant to corrosion. Next one, number 3, should have a unique color, or else should have an attractive or unique color. Should have color, right? Should have unique color. So these are the features of a metal which is plated on a different object by using the electroplating. So it should be shiny for sure, then resistant to corrosion, and it should have a unique color. Next one, mention 2 examples for inert electrodes. Platinum. Go by the symbol PT. Capital P, simple T. Okay, remember that. Next one, number 2, carbon. Carbon means actually graphite. Right? Platinum, and the other one is carbon or graphite. So these are inert electrodes. That means these things are not going to react with the solution, okay, the electrolyte. Right, then, though platinum is inert, it is difficult to use platinum as electrodes. Explain reasons. So we know that platinum is an inert electrode, but however, it's not possible to use this platinum as an electrode in the process of electroplating or electrolysis? It's because platinum is expensive. So therefore we won't be able to use, or the people will not use platinum as electrodes. Okay, however it can be used, but the thing is that is the most expensive metal in the whole earth. Okay, even it is more expensive than gold. Gold is the expensive one that for our knowledge, but however there is another metal which is more expensive than the gold. It is referred as white gold. White gold is platinum, my dear children. Okay, so we can write the answer, because platinum is, right, because platinum is expensive. This is the reason, because platinum is expensive. Next one, mention 2 special things to follow to have a quality electroplating process. 2 special things. Number 1, should provide low current. Low current means, my dear children, like I said in the previous case also, low current means low potential difference. Both the things are correct, but it involves in the same procedure. Okay, so therefore I'll include low current. So should provide low current. We should provide low current. Okay. Number 2, need to use very dilute electrolyte. Right. So first one is should provide low current with low potential difference. Okay, and the next one would be need to use very dilute electrolyte. So we need to use very dilute electrolyte. So these are the 2 special things to follow to have a quality electroplating process. Right then, so we'll moving on to the next question, my dear children. A different type of a question. Here what you have to do is you have to put a tick or else a cross. Right? You have to put a tick or else a cross for the given statements. During electrolysis, electricity is converted to chemical energy. Correct, right? Absolutely correct. Electricity is getting converted to chemical energy. That is correct. Because our result is generated in a chemical reaction by providing electricity. So it is correct. Electricity is getting converted to chemical energy. No problem. Hydrogen gas is giving out a pop sound when burnt. Once again correct. When you burn it by using a splinter, it is giving out a pop sound, right? It is giving out a pop sound. So it is correct. Hydrogen gas is giving out a pop sound when burned. Next one. Copper is an inert electrode. Incorrect. Copper is not an inert electrode. The only inert metallic electrode is platinum. Okay, platinum. Graphite is made by carbon atoms. Correct. Graphite is made by carbon atoms. That is correct. Common salt conduct electricity when powdered. Right? When powdered, not at all. Right? It's not going to conduct electricity when powdered. Powdered means in the same state, right? Solid state. In the solid state, they don't have mobile ions. So therefore, this is incorrect. Next one. During electrolysis of copper sulfate, hydrogen gas emits. Once again incorrect. Copper, during the process of electrolysis of copper sulfate solution, hydrogen gas is not going to emit. The oxygen gas is going to emit. Okay, oxygen gas is going to emit. That's not a problem. Oxygen, not hydrogen. So during electrolysis of copper sulfate, oxygen gas emits, not hydrogen. Next one. Galvanizing is not a process that involves electrolysis. Incorrect. Galvanizing is conducted by using the electroplating process, right? Electroplating means, my dear children, electrolysis, no? right? It's a subcategory of electrolysis, so it is correct. So electrolysis is a process of electroplating. So my dear children, galvanizing is a process that involves electrolysis, right? Here it is given not a process, so it is incorrect. Next one. Metals have mobile electrons to conduct electricity. Metals have mobile electrons to conduct electricity. Mobile electrons, metals, absolutely correct. Even me explained that metals conduct electricity mainly because of having mobile electrons. Next one. To plate gold, electrolyte should also contain gold. Correct. To plate gold, we have to use a electrolyte. We have to use an electrolyte. That electrolyte should contain gold salt. So it is correct. Iron is extracted by electrolysis. This is incorrect, my dear children. Iron is not extracted by electrolysis. Iron is not that much reactive. So therefore, we don't use the process of electrolysis to separate iron from the iron ores. Okay, we use the method called reduction in there. You will learn these things in the next grade. Okay, right. So what are the metals which are extracted by electrolysis then? Sodium, aluminium, calcium, magnesium, those kind of things are getting extracted by electrolysis because they are very reactive than the other metals like iron, right? Next one. Magnesium nitrate is an ionic compound. Of course, my dear children, you ignore about nitrate. Magnesium is a metal, no? So magnesium nitrate definitely an ionic compound because magnesium is a metal. I told you that it's very easy to identify ionic compounds. If there is a metal included, then it is an ionic compound. To quality electroplating, high current should be supplied. Incorrect. If you are providing high current, then the chemical reaction would happen very quickly and the plating will not be a quality one. Right. So these are the answers for the third question, my dear children. Okay, so let's move on to see the next one. Okay, you are given with a fact and you have to name the substance. You are given with a certain fact here, then you have to name the substance over there. Okay, so you have to complete the table by using the fact and you have to write down the correct substance. Number one, giving a bright flame with a glowing splinter. So it is giving out a bright flame with a glowing splinter. Oxygen gas, right? So oxygen gas is the one. As it is a subordinate of combustion, it is giving out a bright flame with a glowing splinter. Next one. Giving a pop sound with a glowing splinter. This is hydrogen gas, my dear children. Hydrogen gas. Hydrogen gas. Next one. Has a red brownish color nature with a luster. Has a red brownish color nature. Red brownish color nature can be observed within copper. So this is copper metal. Copper metal. Has mobile ions to conduct electricity. Mobile ions, that means it is an electrolyte. Electrolytes. Next one. Has mobile electrons to conduct electricity. Definitely this one should be a metal. Right? Metal. Next one. A nonmetal that conduct electricity. A nonmetal that can conduct electricity. Graphite. Carbon is also correct. You know that graphite is made by carbon. So carbon or graphite, both the things are correct. Used to plate on iron to protect from rusting by using electroplating. Used to plate on iron. So this thing is being plated on iron to protect iron from rusting. zinc, or tin is also correct, tin. Okay, zinc or tin, both the things are correct. Okay, right. So for the fact which is given, we completed the substance within the table, my dear children. So let's head on to observe the next question. So here you are given with a experiment, right? You are given with a certain experiment. Now within this experiment, you have to, using the given experiment, you have to answer the questions. Let's see. Here the iron nail is plated with gold. Name a suitable electrolyte that can be used for above purpose. Now the iron nail is plated with gold. So therefore the electrolyte which we are going to use also should be gold electrolyte. Okay, so we can write the answer, electrolyte of gold, like gold sulfate, gold chloride. Okay, electrolyte of gold. Next one, what is the metal plate used in above? Definitely it should be a gold plate. We know that if we are plating gold, then definitely it should be a gold plate. Right. So electrolyte of gold is the electrolyte that we are going to use, and gold plate is the metal plate which we are using here to plate iron nail with gold. Next one. Draw and show the correct connection of dry cells to the above circuit. So you have to show the connection of dry cells. So we'll draw those. This is the positive terminal, as it is mentioned over here also. This is the positive. So positive is the longer terminal, my dear children. Shorter one, again longer one, a shorter one. Right. So this is the proper connection. Always the negative terminal should be at the negative terminal. We need to include the negative terminal on the object and positive terminal on the metal plate, right? Okay, next one. Write two observations from the setup. Two observations from the setup. So the two observations are very simple. Number one, gold plate is getting dissolved. Gold plate is getting dissolved. Next one, number two. Second one, gold is plated on the iron nail. Right? Gold is plated on the iron nail and gold plate is getting dissolved. These are the two observations from the setup. Okay. Right. So let's head on to see the next question. Once again, you are given with another one. Above setup shows the electrolysis of acidulated water. Write two observations from the setup. Two observations from the setup. Acidulated water is the one which is used. So, very simple. Number one, gas bubbles emit from positive and negative terminals. So gas bubbles emit from positive and negative terminals. This is the first observation. Then the second one, my dear children, can you remember? Second observation would be more gas bubbles emit from negative terminal. Gas bubbles emit at a higher rate right? Gas bubbles emit at a higher rate near the negative terminal. Right, so gas bubbles emit from positive and negative terminals. This is the first observation during the electrolysis of acidulated water. Then the second one, gas bubbles emit at a higher rate near the negative terminal, because negative terminal contains hydrogen plus ions which is getting converted into hydrogen gas. So more hydrogen gas is getting emitted from the negative terminal. Right, then the next one. Write a suitable experiment to identify gas emitted near the negative electrode. So near the negative electrode, my dear children, you know that near the negative electrode, hydrogen gas is going to emit. So when a glowing, right, when a glowing splinter is added, right, when a glowing splinter is added, it will give out a pop sound. So when a glowing splinter is added, it will give out a pop sound, right? It will give out a pop sound. So this is how to identify hydrogen gas which is getting emitted from the negative terminal, as there are hydrogen plus ions in here. Okay. So the experiment to identify gas emitted near the negative electrode would be when a glowing splinter is added, it will give out a pop sound. Okay. Next one. Write a suitable experiment to identify gas emitted near the positive electrode. So when a glowing splinter is added, it will give out a bright flame, right? Because of the presence of oxygen gas. So we can write the answer. When a glowing splinter is added, when a glowing splinter is added, it will give a bright flame. Right? So when a glowing splinter is added, it will give a bright flame. So to identify gas emitted near the positive electrode here you can observe OH minus. That means oxygen gas is getting emitted from the positive terminal. That means, my dear children, when you add a glowing splinter, right? When you add a glowing splinter, then, my dear children, what will happen? It will give a bright flame. Okay, it will give out a bright flame. Right then. Okay, the sixth question. Let's see what is the sixth question is. If you are given with a copper necklace to plate silver using electroplating, draw and show a labeled diagram. You are given with following substances: silver plate, 9-volt cell, silver chloride solution, beaker, copper necklace, carbon electrodes. So, in order to plate silver, right, we need to plate silver within a copper necklace, my dear children. So, first of all, we'll take the container, the beaker. Then you know that if you are plating silver, then we need to use this silver chloride solution. So here we go, the solution, right? Solution. Silver chloride solution. Then we need to plate silver. Then we need to use a silver plate. Let's use a silver plate then. The silver plate. So this is the silver plate. Okay. So this is the silver plate, my dear children. So you know that silver has a unique like ash color nature, and it is also lustrous. This is the silver plate then. Right. Then the copper necklace. Okay, the copper necklace. Let's draw the copper necklace then. Right. So this is the copper necklace. Okay. So I have used a distinct color for copper necklace. Then my dear children, I'm going to use the solution. So the solution you know already. This solution should be silver chloride solution. Silver chloride solution. Then this is the silver plate. Silver plate. And this is the beaker. Right? Beaker. Then my dear children, the dry cell. Positive terminal to the metal plate and the negative terminal to the object like this. So this is the 9-volt cell. Then finally this is the copper necklace. Copper necklace. Right. So these are the components, my dear children. So this is the beaker, the positive terminal. Positive terminal is the silver plate. Negative terminal, this is the copper necklace, the 9-volt cell. Then we use the silver chloride solution as the electrolyte using the beaker. Then we provide electricity by using the 9-volt cell. We don't need carbon electrodes in here, however it is been given for you guys. That is to mislead. So don't get misleaded. This is the way of doing the electroplating process of plating silver on this copper necklace. Okay, so always remember, silver plate should be used as the positive terminal. Right, my dear children. So with that, we have finished several MCQ questions with several essay type questions related to the lesson electrolysis. So this is the 10th lesson, my dear children. So we have finished the 10th lesson in your science syllabus. So in the next day, I'm going to start the next fresh new lesson, the lesson 11, and I hope that you will stay with me with the and I hope that you will join for the 11th lesson as well, like this. So my dear children, I'll be meeting you soon with the lesson 11 to discuss about the density, my dear children. Right? So until we meet again, it's time to say goodbye.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.